Hey there, your eights. In this video here, we're going to be looking at the area of kites and rhombus and trapezium. Really, the only thing that you got to take your notes in is that knowing how to identify when you have a kite, rhombus, or trapezium. Whereas the formulas, you can probably memorize these formulas. The kite and the rhombus, you use the same formula, and then trapezium is different. That's about it. So there's only two formulas to take down, but the area formula for a kite is half times diagonal 1. So from corner to corner, see that corner? That's diagonal 1 times the other diagonal, which is this one, and then you halve it. Okay, same thing with a rhombus. You will be multiplying the diagonal 1, okay, and then you times by diagonal 2, so corner to corner, and then you halve that, and that will give you the area. Okay, now in this case, what you'll be filling in the spaces below, well, this length is clearly y, so that length there is y, and then the other diagonal is clearly from here to here is the same length as that, so that's times x. Okay, so that'll help you remember. And then same thing with this one, if you label it the way I'm doing now, so I'm going to label this is the length of x from here to here, and then I'll do another color, from here to here is y. Okay, so then again, you've got times by y, times by x, and then halve it. Now, though the areas are the same, they're actually different shapes. And a lot of students mix between rhombus and kite. So the symbols matter here. Make sure, how do you know when you have a rhombus and a kite? Well, it's actually in the dashes. You see, a rhombus is like a square, but tilted. So all the sides must be the same. And we do that with a dash. We dash one side, one side, one side, one side. So all four sides have to have the equal length. Whereas if you look at a kite, you see how that has one dash, two dashes, and one dash. They are not all equal. So that's how you know it's not a rhombus. Another thing to know, well, how do you know it's a kite and not something else, right? Like a parallelogram or something, or a trapezium. Well, one of the special things about kites is that usually we say opposite sides are the same, but in a kite, you'll find that opposite sides, so the opposite of this side is this, they're not the same. And the opposite side to this, they're not the same. But what's funny is that they're the same when they're next to each other. And the special name for that is adjacent. Adjacent means that they are next to each other. So they have adjacent sides of equal length. That's what we say. That's how you know you've got a kite. Okay? And then note here, I said formula for kite and rhombus are the same but different to and I want you to feel here, parallelogram. So a parallelogram feels like it could be like a rhombus because it's meant to be a rectangle but skewed, right? But one of the things is, why isn't the formula the same for a parallelogram and a rhombus? And the answer is because the diagonals in a rhombus actually intersect at 90 degrees. Okay, so they actually intersect at 90 degrees. Kind of similar to the kite. See how the diagonals intersect at 90 degrees? That's why the formula is the way it is. Okay? Whereas a parallelogram, most times they don't, but they can intersect at 90, but most times they don't. Okay? So there you go. So opposite sides are equal, not equal. So this one here, not equal. So hopefully now you can tell when you have a kite and when you don't have a kite, and all sides are equal. So let's do a bit of a test to see if you can picture it. So think about a kite, think about a rhombus. Let's go and picture some. So let's have a look. Is 2A a kite or a rhombus? Think. It's rhombus. Hopefully you got that right. B, is that a rhombus or a kite? It's a rhombus. Okay, all sides are the same. All the dashes there are telling you. Okay, so dashes are all the same, so it's a rhombus. What about this one? C. Yes, rhombus again. All sides are the same. Let's have a look at E. Yes, it's kite. You see, not all sides are the same, so hence that's a kite. Okay, kite again. And obviously the last three is neither a kite nor a rhombus. And that's, if you were able to keep up with what I just said there, that's identifying the shape first. Okay, once you know the shape, then you can then work out the area by following the formula. And last one over here is a trapezium. How do you know you have a trapezium? Very easy. You just look for one pair of parallel lines. So note they only have one pair of parallel lines. Okay, so you can draw, so as long as you draw two lines that are parallel, like this, There's only one pair, and you can connect this in any way as long as they're not going to be parallel. That is a trapezium. Right there, that's a trapezium. You could have a trapezium that is like this, okay? So like that, they're parallel. There's one pair that's parallel, and then as long as the other two sides are not parallel, then that's a trapezium. Okay, so if you have a look over here, let's go look at the diagrams before. Can you see how there's the last three, G, H, and I, they're all trapeziums because they all have only one pair of parallel lines. See that? They only have one pair. They don't have two. Whereas a rectangle has two, a square has two, parallelograms have two, trapezium's the only one that has one pair. Now, if you're able to identify it's a trapezium, then the rule for it is half times A plus B times height. What is A and what is B? A and B are the two parallel lines. That's what it is. A and B are the two pairs of parallel lines. So wherever the parallel lines are, that's where A and B is. Add those two together, times by the distance between them, not the diagonal. It's always the vertical distance between the perpendicular distance. It has to be 90 degrees with each other. That's your height. Okay, so the height is where the perpendicular distance is. That's your height, not the slant, not the slant. Okay, and that's it. Times the height, half it. So note A and B are the pairs of parallel lines. That's it. So now that you've got the formula, you've got the theory, you can now answer these questions. So you can see here, what shape is it? Hopefully you've noticed that it's a rhombus. Area is half times D1, diagonal 1 times diagonal 2. So this is 6, and this 4 here represents the distance from here to here. So it's really just half times 6 times 4, and half of 6 is 3. 3 times 4 is 12 squared meters. Okay, you can copy those notes down or you can pause the video. Same thing with the next one. What shape is this one? B. Have a think. Trapezium. Good. And then now you look at your notes again. What's the area formula for a trapezium? It was half, bracket, A plus B times height. Very good. So remember, A and B are your two parallel lines. So where are my parallel lines? It's here, 4 and 10. So it's 4 plus 10, then times the height. Now the height is the distance between these two lines. It has to be perpendicular. Okay, so it's the 5, not the slant. Yeah? So times by 5. So here on your calculator, you can type in 4 plus 10, which is 14, times by half, and then you times it by 5. Half of 14 is 7. 7 times 5 gives you 35 squared meters. And your last example is obviously, this is a kite, okay? And again, I know they didn't show you enough symbols here to tell, but we can already tell not all sides are the same and there's no parallel lines there. So we can say this is a kite, and they've sneakily put this 30 here to tell you this is 30 and 30 and this is 30. So the height, the diagonal length from here to here is actually not 60, but 60 plus another 30 gives you a total of 90. So this is a kite. Formula is half times diagonal 1 times diagonal 2, and diagonal 1 is actually 90 centimeters, and then times by the other diagonal, which is this length here, which is 60, not 30. Okay, so you have to do a bit of thinking before you multiply these numbers together. So I'll do half of 60, which is 30, and 30 times 90, which is easier to work out. That's 2,700 square centimeters. Again, you can use a calculator. All right, there you go. So that is it for today's lesson. It is pretty straightforward. 4D, just two formulas to work with, and you got to identify the three different shapes. Okay.